Welcome to GearVR Framework Tutorial Lesson 4. We're going to learn about components. In this lesson, we will actually make a little game out of the Lesson 3. We'll put a particle system in using components, and it will generate multiple balloons. So components are the way you extend your application, and they attach to scene objects. So every scene object has a list of components, and you can attach them and detach them at runtime. Now there's only one instance of each component type allowed. So you can't put 2 lights or 2 cameras on a scene object. And the component type is something that, as you'll see, we get to decide what are the component types. They're not built into the system except for the native components. So GearVR component is the base class for all components. There are native components, and these are actually implemented in C++, and we just have Java wrappers for them. These would be things like cameras and render data and transforms that the actual rendering engine needs to understand and look at. Behavior components are completely written in Java. Now, there's a couple of functions on components that are important. GetComponentType returns the type. This is how you know what kind of component you have, and this is how the scene object attachment determines whether you already have one of that type installed or not. Then setEnable and allows you to disable or enable a component, and if it's disabled, that means it's in the scene, but it's actually not doing anything. And then getObjectOwner will get you the scene object that the component is attached to. Native components are the ones here in the list. These are things that are partially implemented in C++ and reference data structures that are actually in the C++ layer. These include the transform, which is the matrix that gives the position and orientation of a scene object. And this is very useful because, as you'll see in our example, we're going to use the transform of the scene object to animate our particle balloons. The GearVR render data has the mesh and material to render. Now, all scene objects have a transform, but not all scene objects have these other components. These are optional ones. GearVR render data is only there on displayable components that actually are visible in the scene, but there's scene objects that could have components like lights or cameras that aren't visible in the scene, but nevertheless they're there and they're interacting. Last lesson we saw collider, an example of collision geometry component. GearVR behavior is the base class for components written in Java. All of these must implement getComponentType to return a unique type for the component. Now that's pretty easy because GearVR behavior new component type is a function that will generate a unique type, but you should only call it once at the beginning and not again because it generates a new type every time you call it. There are several callbacks that GearVR behavior uses. You get an onAttach whenever your component is attached to a scene object. When it's detached, you get an onDetach, and then onDrawFrame is called once per frame. GearVR Picker is an example of a Java-only component derived from GearVR behavior. Now we're going to define a particle emitter component, and this component will emit particles over time from a specified area. So the velocity and the direction of the particles are going to be randomly generated, and we'll be able to specify the range. So here you see we're going to have the total number of particles. That's all the particles that are active and existing at all. That will be capped so that we'll never make more than this number. We'll have a maximum number of active particles, and at that point you won't make any new particles until particles have been deactivated. An emission rate, which will control how many particles per second, and a max distance, which will control how far away particles go from where they start before they disappear. So all of these things together will help you control how many particles are in the scene. And then our velocity and direction are a range, and this little range class is in the sample. I'm not going to go over it. All it does is keep 2 separate objects, a minimum and a maximum. So the velocity will be the range of velocities for the particles, the direction will be the range of directions, and then the emitter area will define what is the range in the XY plane over which particles start. And particles are emitted from the XY plane starting at z equals 0, and they're emitted towards the negative z-axis. Now, this may not seem terribly useful, but actually you attach the particle emitter component to a seen object, and then it will use the seen object's position and orientation to control where the emitter is emitting from and what direction the particles will go. So you can completely control it, and we'll show that in the next demo. Now, the particle emitter itself will have an emit function, and this is the function that we have to emit the next particle. And these particles are kept around over and over again. So the total particles gives you the total number of particles you will ever emit, upon which you will reuse particles as they become available. So we have a free particles list and an active particles list. The active particles list is the ones that are in the scene right now that you can that are actually moving, and then the free particles list are ones that are available to be reused that have already been made, but now they're not being used anymore. Now, a particle is a scene object that has got a particle component on it. So the way you talk to the particle emitter about how to construct its scene object is you make an interface, a make particle interface, and this is part of the particle emitter class, and it has a function called create that takes in the context and outputs a scene object. So every time you want to emit a particle, you'll call this function from the interface that's provided, and then it'll make a new scene object, and it's up to you what kind of scene object you want to make. For flow control, we have the on draw frame listener that if you put an on draw frame override in your GVR behavior subclass, then what you'll get is you'll be called every frame, and this is automatically going to happen. You don't have to do anything special to get this because GVR behavior does this for you. Now I'm going to call a step function every time on draw frame is called, but only if my component is enabled. So it's up to the individual components how they use the is enabled flag. So here we're just going to not do anything. We won't emit any particles if our component is not enabled. Now we're back in Android Studio, and we're going to add the particle emitter class. By now this should become familiar. We make a new class and we add it to the scene, and then we populate it with the stuff that's right from our example. So in this case, we're going to make the particle emitter class, and as you can see, here's a little range class that I referenced in the sample. There's the implementation for it. Here's our make particle interface. We've defined all of our public variables, and here we have our setup, our component type, and our on draw frame, our step function, and functions to get direction, velocity, and position by computing the area, velocity, and direction randomly. So as you remember, the step function is where our flow control is. Each frame we move all the particles, and we'll stop the particles which have gone out of range. So this is where we call our particle move function, and then we compare it with the maximum distance so that we can free the particle and allow it to be reused. Here is where we check whether or not we need to emit a particle again in this frame. Now this particular implementation of a particle system will emit at most one particle per frame. That's a simplification. Now we're back in Android Studio, and we're going to add the particle emitter class. By now this should become familiar. We make a new class and we add it to the scene, and then we populate it with the stuff that's right from our example. So in this case, we're going to make the particle emitter class. And as you can see, here's a little range class that I referenced in the sample. There's the implementation for it. Here's our make particle interface. We've defined all of our public variables, and here we have our setup, our component type, and our on draw frame, our step function, and functions to get direction, velocity, and position by computing the area, velocity, and direction randomly. So as you remember, the step function is where our flow control is. Each frame we move all the particles, and we'll stop the particles which have gone out of range. So this is where we call our particle move function, and then we compare it with the maximum distance so that we can free the particle and allow it to be reused. Here's where we check whether or not we need to emit a particle again in this frame. Now this particular implementation of a particle system will emit at most one particle per frame. That's a simplification. Normally the logic there would be a little bit different. So far we've made two classes, but we haven't really done anything with them. So here is how we add the emitter. The emitter is done in onInit, and we first have to set up a scene object. We'll call it here the particle root, and this scene object will be what the particle emitter component is attached to. And the particle emitter component will be rotated and positioned to emit upwards and in front of the viewer. So here's where we transform, like we rotate 90 degrees about the x-axis to get it to go up instead of forward. And then we move it out a little and down a little so that it's kind of more near to the bottom of the scene, and the particles will be emitted upwards. Here we can set the emitter properties, and we're going to emit 3 particles a second. We'll have a total of 10 particles, and when particles are more than 10 meters away, they'll disappear. So that our velocities will be in the range between 2 and 6, and here is the area in the XY plane that the particles are emitted from. Remember, when we're going to rotate that area, and it's going to become the XZ plane, and particles will be emitted up along the positive Y-axis. Here is the scene graph snippet that shows the emitter. Now, all the particles that are emitted will be underneath this emitter. So even though they're being emitted forwards, when you rotate the emitter upwards, that transformation will apply to the particles as well. And finally, here is how we make the particles themselves. We make a new make particle interface, and we define the create function. And in our case, we're going to define the create function to return our make balloon. So every time we make a balloon, it'll be a new particle. And we're going to show how we would do balloons of varying colors so it doesn't get too boring. So now we're going to add the particle emitter to our main application. And in order to do this, we would put the code from the sample that we just went over into the system. So we're going to put it right here, and instead of adding this balloon, we're not going to add this balloon because the balloon is now going to come from the particle emitter. So we're going to add this, and now we have to define the particle system itself. So we would go up here and put that right next to the pick handler definition. Okay, and now we should see a successful build. Now we should be able to run it on the phone and see what it looks like. So let's take a look at it. Here we see all of the balloons, and the one that you're currently looking at is going to be a different color than the ones that are being generated fresh, which are all pink. And if you look down, you can see they come from the bottom and they go up and then they disappear when they get to the sky. So that's our distance logic working. So this is all we have now, and we're going to continue on and try and make the balloons more interesting in the next section. Wouldn't it be more fun if all of the balloons didn't start out the same color? So what we're going to do in this section is show how you would create particles that are of different colors but share the same mesh. So what we have here is a function to make materials, and it just makes a new material and puts it in a table, and this material will differ only in that their diffuse colors are different. And so here we have 6 different colored materials. And then to our make balloon, what we're going to do is randomly choose one of the materials that we've made in this table and use that as the material for the balloon, but we're going to pre-generate the sphere mesh. So let's see how we would do that. First, we would add our function to make materials, and it would want an array list, so we'll show it where to find array list. And then we want to add that capability into the balloon function. So we go to our make balloon, and we first decide that perhaps it should have the material index. So let's go find make balloon and put a material index in it. Okay, put the material index in, and then we'll attach one of the materials from the table into that. And now we need to define the materials table, because we need to have a random number generator too. I think we will need all these things. So we're going to put these up at the very top on the declaration section. So we have random and a sphere mesh, which we have yet to define, and our materials table. So to make a sphere mesh, what we would do is just make a sphere and then save the scene object. So let's do that. We'll put that inside right before we do our particle system, because we have to have this defined before we do our particle system. So we've made our materials and we've made our sphere mesh. Before we try our new colors out, we need to update our pick handler to not change the color, only just to remember the picked object. So let's do that now, and what you'll see there is the picked object is remembered, but we took out the part that was setting the diffuse color and making it different. We're also going to replace the touch event, and instead of having the color change, we're just going to stop the particle system, and then the balloon will disappear. Before we can run our application, we have to also remove the old logic that was setting the material of a specific color, so that we can just use the material from the table. Now let's build our application and see what it looks like on the phone. This time we get balloons with different colors, and when we pick one of them, it disappears. As you see, I'm clicking, and as I click them, they're going away. So this concludes lesson 4. Let's look at the scene graph that we've created in lesson 4. And you can see that we've added particle components and a particle emitter component. But other than that, our scene graph hasn't changed much. We just have more particles than we did before. It's still kind of a boring game, but we'll get there. And lesson 5, we'll learn how to add sound effects and do some scoring. Thank you, and I hope you enjoyed lesson 4.